Okay, geometry students, this is your 3-1 through 3-4 quiz review. Got about 6 problems to do. Should be a good review for your quiz coming up on Thursday or Friday. Alright, so first one, we have to use the diagram to name each of the following. Assume that lines look parallel are parallel. So, the first one, number 11, we're looking for a pair of parallel planes. Well, the only 2 planes that I know for sure are parallel are going to be the top and the bottom. So I will call the top plane, and I'll use 3 letters. Let's go in the top plane JCD is parallel to plane, and then the bottom plane, I know that A, B, and H are part of that plane. So there's a pair of parallel planes. Okay, next, all lines parallel to DH. Well, if you look at DH runs vertical. So any line that's vertical is also parallel to DH. So that would be GB, and they want lines. You could use segments, but they want lines. FA runs vertical. JE runs vertical. CL runs vertical. So again, if you look at where DH is, all the lines going in the same direction are parallel. Okay. And then the last one, 14. Name 2 lines that are skew with EJ. So EJ is going up and down, vertical. So you need to find lines that don't go in the same direction, but still will not intersect. And again, it's kind of tough with the way that this is angled. But we're looking for lines that will not intersect. I believe that CD is a skew line. It goes in that direction. I believe that FG would be a skew line. And I'll highlight these in a second. I think that DG would be a skew line. I believe that BH is a skew line. Again, these are all lines that go in the not in the same direction, but will never intersect JE. So what I got? I got CD, DG, BH, AB. I don't ever think will intersect. And I think that's all of these skew lines. So again, just to trace them. So CD goes that way, will not intersect. FG goes this way, will not intersect. DG goes that way, will not intersect. BH also goes the same way DG does, will not intersect with EJ. And AB. Oh, one more, back here. LH is also skew. Okay, so again, I believe I got them all. But again, it's just non-coplanar lines that will never intersect. That's skew. All right. Okay, very good. Next problem. We are going to find the measures of all the numbered angles, and we have to justify our answers by relating them to one of the either the given angle or another angle. So I'm going to start with angle 1. I know that it's 65 degrees because it is vertical with the given angle. And then I'm going to go with angle 2. Now, angle 2 is going to be a linear pair. So to find angle 2, I'll do it up here. We need to do 180 minus 65. Remember, when you have these parallel lines and transversals, there's really 2 angle measures up there, an acute and an obtuse. Half of them are acute angles, half are obtuse. So the measure of angle 2 is 115. That's going to be a linear pair with the given angle. And the same thing with angle 3. Angle 3 is also a linear pair with the given angle. So it's 115. Linear pair with given angle. And now we need to go down to 4, 5, 6, and 7. Here's where the new stuff begins. Angle 4 is going to be 65 degrees because it is a corresponding angle with the given angle. Angle 5 does not share a relationship with the 65 degree angle, so I'm going to say angle 5, I'm going to compare it to angle 3. It is an alternate exterior angle with angle 3, so it's the same as angle 3, 115. alternate exterior with angle 3. Then I'm going to slide down just a smidge to get the other 2 on here. Angle 6. Angle 6 is a same side interior angle with 65 degrees, so it's supplementary, so it's 115. Same side interior with the given angle. And then the measure of angle 7. And angle 7 is an alternate interior angle with the given angle, so they are congruent. 65 degrees. Alternate interior with the given angle. So make sure you can justify where you're getting your angle measures from. But again, notice 4 65 degree angles, 4 115 degree angles. That should be the case on most of these pictures. Alright, next we're going to do a proof. Write a 2-column proof to prove the corresponding angles theorem. Therefore, we can't use it. Can't use it. Okay? So I have my picture. Here's my given. L parallel to M. Alright. So if I look at the picture, if L is parallel to M, which angle pair can I make a comment about? Well, let's look at 3 and 6. 3 and 6 are same side interior angles. Since L is parallel to M, same side interior angles are supplementary. Angle 3 and angle 6 are supplementary. That's the same side interior angles postulate. And now, if I look at the picture, I also know that 2 and 3 are supplementary because they're a linear pair. Now again, I want to link 6 to 2. I have 3 and 6, so I can link 3 to 2 as well. So angle 3 and angle 2 are supplementary. And this is the linear pair postulate, which says if 2 lines form a linear pair, then they are supplementary. And now look at what we have. 3 is supplementary with 6. 3 is supplementary with 2. That means that 6 and 2 are congruent. Angle 2 is congruent to angle 6. And this is because of the congruent supplements theorem. Both supplementary to 3. Alright. And there's the proof. And you've proved the corresponding angles theorem. Okay. Remember, if you're proving a theorem, you can't use it. Alright. And make sure you remember that that congruent supplements theorem. We use that a lot. I'll put a star. Right? Okay, good. Next, another proof. Okay. But now look at this time. You're trying to prove lines parallel. Remember that if you're trying to prove lines parallel, you have to use one of those converses. Now they're the same 4 ideas, alternate interior, alternate exterior, same side interior, corresponding, but now it's just the converse. So we'll start with the given. Angle 1 and angle 3 are supplementary. That was given to me. And now let's take a look at angle 1 and angle 2. They form a linear pair. Angle 1 and angle 2 are supplementary. That's because they form a linear pair. That's the linear pair postulate. And now, similar to the last proof, and again, I told you we're going to use this a lot. If angle 1 and angle 3 are supplementary, angle 1 is also supplementary to angle 2. What do I know about angle 2 and angle 3? They are congruent. And this is because of that congruent supplements theorem. They're both supplementary to angle 1. Sup to angle 1. Right, if they're supplementary to the same angle, then they are congruent. And if 2 and 3 are congruent, look at their situation. 2 and 3 are corresponding angles. You've just shown that corresponding angles are congruent. Right here. If corresponding angles are congruent, lines are parallel. This is the converse to corresponding angles theorem. Converse. Remember, you got to use a converse when you're proving lines parallel. Converse. Okay? And there's the proof. Alright, so keep that congruent supplements theorem in mind, right? We've used it a whole bunch. Okay. So that's your proof practice. Next, 5. We need to find the value of x that makes L parallel to M. So the idea here is, what type of angles are these, and what needs to be the relationship for L to be parallel to M? Well, these are alternate exterior angles, and by the converse to the alternate exterior angles theorem, these two angles must be congruent. 3x minus 33 must equal 2x plus 26. And we solve. Subtract 2x. X minus 33 equals 26. Add 33. X equals 59. And there's your value of x. That's the value of x that would make these two angles congruent. If you want to check, you could plug it back in and check. I'm very confident, though, that I did the problem right, so I'm not going to. But that is all because of the converse to the alternate exterior angles theorem. If x is 59, these two angles are congruent. L is parallel to M. Okay, last problem. Here we go. 6. It says A, B, C, and D are different lines, distinct lines. For each combination, tell how A is related to D. Justify your answer. So what you could do is you could draw me a picture, okay? Or you could use the theorems. And I don't care what you do. I'm going to use the theorems, and then I'll draw a picture. So, theorems. Way 1. I'm going to use the first two. If A is parallel to B, and B is perpendicular to C. This is the perpendicular transversal theorem. Because A and B are parallel, and C is perpendicular to one of those parallel lines, that means that C is perpendicular to the other. Perpendicular transversal theorem. Okay, so now I have this. So I've used this, I've used that. I've used A parallel to B, B perpendicular to C. So now let's combine A perpendicular with C parallel to D. Same idea. You have a pair of parallel lines, and A is perpendicular to one of those parallel lines, so A must be perpendicular to the other. And this is again by the perpendicular transversal theorem. And there's your conclusion. Okay? So that's the theorem's way. Now let me slide down. If I'm going to draw a picture, which I'm okay with, A is here, parallel with B, so they're parallel. B is perpendicular with C, so here's C, perpendicular, and C is parallel to D. So there's the picture. So if you just extend the lines, right? Extend B, extend C, extend D, extend A. There. Boom. A and D are perpendicular. A. So I'm okay with the drawing as well. Okay? Either way you want to do it is fine. Alright, so hopefully this helped. Just a quick little 6-problem thing. Make sure you do your note cards and practice some problems. Okay, and we'll see you on Thursday or Friday.